In section 2 of our triangle congruency chapter here, we're going to look at 3 things that prove congruence in triangles: AAS, SSS, and ASA. And we'll talk about those in a few minutes here. And we're also going to review some key theorems and postulates used in proving triangle congruence. The reflexive property, which says you can say that something's equal to itself. A lot of times we're going to say that a side is equal to itself, or we may have to state that in a proof. Parallel lines and the angles involving them, corresponding, alternate interior, alternate exterior, things we've talked about. Isosceles triangle theorem, which says that if you know 2 sides are equal, then the 2 bottom angles are equal, or the converse of that is true. Substitution, addition and subtraction properties, supplementary and complementary angles, midpoint, angle bisector, which says then you can say the 2 angles are equal to each other, the 2 smaller angles. Segment bisector, likewise with the 2 smaller portions of the segment. The median, which comes from an angle and cuts the opposite side in half, and also perpendicular bisector. So let's look at the first thing that proves triangle congruence. If you have this situation, which is called AAS, and it stands for angle, angle, side congruence. Angle, angle, side. It says if 2 angles in the non-included side of one triangle are congruent to the corresponding angles and sides of a second triangle, then the 2 triangles are congruent. So look at these 2 triangles here, and we can state that they're congruent because of this situation. If you notice, angle C is shown to be congruent to angle Z in the second triangle. Angle B is shown to be congruent to angle Y in the second triangle. And then we have side AB shown to be congruent to XY with that tick mark. Okay? And because this is an angle, angle, side situation here, AAS, because if you think about angle, angle, side in that order, what we really have is angle, angle, side. I have angle here, and then if I'm working my way around clockwise, so I'm kind of going around this direction, I go angle, angle, and then side. So we have an angle, angle, side situation. We call that side the non-included side. So I have 2 angles and then side. And this can work, this is obviously going clockwise, but it can work counterclockwise as well. But hopefully you see why it's an angle, angle, side situation. Okay, let's go to side, side, side congruence. This one's pretty cut and dried, straightforward. If you notice, side AH is congruent to side RS, and these aren't sitting the same direction here. Side AT in this triangle is congruent to IS over here, and side HT is congruent to side IR. So this one's pretty straightforward. No matter if you go counterclockwise or clockwise, we're not dealing with any angles, so it's side, side, side. SSS shows triangles are congruent, or proves triangles are congruent. If we go to the next one, or the last one in this section that we're going to use, it's ASA. So if I look at ASA, angle, side, then angle, now we have the included side. Notice the S is between the 2 A's. And look at our picture here. I have angle C is congruent to angle R. Okay, and then I have a side CE is congruent to side RN, so this is the angle, then the side. If I'm working my way around this way now, I'm kind of going counterclockwise, and then I get to angle E, which is the angle here that's congruent to angle N. So it's angle, side, angle. So the side is between the 2 angles, thus the order of the letters there. Okay, so on this next example here, we're going to give the congruent statement, then the reason the triangles are congruent, so one of these 3, and then we're going to use CP, corresponding parts, congruent, triangles, congruent, to identify the rest of the remaining corresponding parts. Okay, so we're going to write the congruency statement. So I'm going to say triangle, and I'm just going to go to this first triangle over here, and I'm going to pick an order to write the letters. So I'm going to say ABC, and we're going to say that's congruent to triangle. Now if you notice, angle A here is between the sides, or the side that has 1 tick mark and 3 tick marks. So if I look over here, match up the corresponding letters, here's 1 tick mark, here's 3 tick marks. So I have to start with R on this one over here, because A corresponds with R. Okay, then I went to B next. If I notice B here, notice it's between the 1 and 2 tick marks. So if I go over here, that would be I. Notice it's between the 1 and 2 tick marks, so I has to come next. And then obviously T is the last one. There, that's the congruency statement. stating the two triangles are congruent. The reason, so I would say by side, 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 because we're dealing with three sides. So we don't really have any angles congruent. So it's side, or shown to be congruent. So it's by side, side, side. Now, they want us to do the rest of the remaining corresponding parts here. Use CPCTC. So now once we know the triangles are congruent by side, 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 then we can say, now we already know all the corresponding sides that are shown. So we know that angle A would be congruent. Now notice A is my first thing in the congruency statement, so I'm going to go to angle R. I'm going to go angle B is congruent to angle I, if I'm matching up my second letters, and angle C is congruent to angle T. So that would be the remaining things, because the three sides are already shown to be congruent. Okay, use the picture below to answer the following questions. What do you need to prove the triangle is congruent by ASA? Okay, so we need angle, side, angle. So if you notice, what am I given in the picture? That angle and that angle are congruent. Angle C and angle F are congruent. I want an angle, side, angle. Notice the S is between the two A's, so I got to have the side that's between the two angles. So this side would have to be congruent to this side. So I would need to have CB, side CB, congruent or equal to side. Now I said CB, so you should say FE in that order here. So FE, because if you notice C and F correspond. Okay, so let me erase here a little bit. Okay, now let's go to the second thing. What do I need to prove the triangle is congruent by angle, angle, side? Okay, so now I have angle, 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 angle. Okay, now you actually have a choice here. If I go this way around, I would need to know that AC, okay, which I'm going from blue around to red, then I would go this way around, and that would be then FD. So I could either have, let's call it CA congruent to FD, okay, or I could have if I know this angle and this angle, and then this angle and this angle, if I'm going the other way, I could go this way around, and then it would be side AB here, okay, and then side ED. So I could have AB congruent to ED. Either one of those would work. Write the congruency statement. So let me erase here a little bit and clear the picture up so we can write the congruency statement. We've got to match up corresponding vertices. So I would say triangle ABC. I'm just going to go in alphabetical order there. And don't assume that it's alphabetical, but for the first one you can just pick a way to write it. And then notice I'm doing the one that was without a mark. Okay, so A corresponds with D, and then I went to B, which corresponds with E, so it would be D, and then E, and then C corresponds with F. Are these triangles congruent? If so, by what reason? If not, why not? Okay, if you look at this, we do have a couple sides shown to be equal here. Okay? And then we've got this angle and this angle. and then we have this angle and this angle. But if you notice, we're not really matching up corresponding sides here, so this is no, and I would just say the reason being corresponding sides don't match up. Because if you notice, you go around this way, it looks like an angle side situation, or if I go this way around, actually, I have angle side, 1 mark to 2 mark angle to the thing. But if I go 1 mark to 2 mark, then it would have to be this side, and they don't match up.